In this video, in the Universe Sandbox simulator, I'll create a system with 5 stars, 1 blue-white star, 3 red dwarfs, and 1 brown dwarf. The system will have its own planets and even life. First, let's create a 5-star system, and I'll start with the main star of this system. I've chosen the star Sirius for this, but in my system, this star will be named Helion. Next, at a distance of 0.25 astronomical units from Helion, Barnard's star, a red dwarf, will orbit. But in my simulation, this star will be called Pyros. Now, I'll create a barycenter for these 2 stars. From here on, I'll just place the stars in orbit around Helion, or around the barycenter. Anyway, the 3rd star in the system will be TRAPPIST-1 at a distance of 1 astronomical unit. This is another red dwarf in the system. And in my system, TRAPPIST-1 will have a different name. This star will be named Rubra. Next, at a distance of 20 astronomical units, Tigarin's star will orbit. This is the 3rd red dwarf type star in this system. And in my system, this star will be named Nox. And the final star, if you can call it that, is a brown dwarf, which will orbit at a distance of 70 astronomical units from the central stars. This is how I made this brown dwarf, naming it Umbra. It has a mass of over 17 Jupiter masses and a radius slightly less than 1 Jupiter. The average temperature of the outer layers is 866 degrees Celsius. And basically, this is what it looks like from all sides. A typical brown dwarf. Now let's check the stability of this 5-star system. As we can see, the star Helion and its nearest stellar companion, so to speak, are basically orbiting stably in their orbits. By the way, we can see the habitable zone. This is mostly the habitable zone of the star Helion. For the red dwarfs, as you can see, these habitable zones are very small, and they're just located inside the red zone of the star Helion. And further out, the star Nox is orbiting normally. I'll speed up time even more. As we can see, at its closest point, the star Nox will pass quite far from Helion's habitable zone. I plan to place planets here in this habitable zone. I don't want this star to interfere with me. The brown dwarf Umbra passes even further away and is basically at a safe distance. I think the system will be stable. Now I'm going to add planets to this system, and I'll add the first planet into orbit around the main star, Helion. The first planet in this system will be a dwarf planet orbiting at a distance of 2.5 astronomical units from the main star. In my system, this planet will be called Sinus. It won't have an atmosphere. Now I'll customize the appearance of this planet. I'm using the custom mode here. The simulator immediately colored the planet in these colors for me. So basically, the low elevations on this planet will be like this, the middle ones like this, and the high ones like this. And look at what an interesting planet it turned out to be. I'll also increase the surface contrast. It'll look even better that way. And we can even raise the mountain heights on it a little bit. Something like that. Regarding the temperature, it'll be 127 degrees Celsius here. You might ask why that specific value. I'll tell you guys, I've been testing all these planets that will be in this system off camera, checking what the approximate temperature on them would be. And so, as not to drag out this video, I'll just set the values that I got during the test. So in general, here's the first dwarf planet in the system. Now further out, at a distance of 4 astronomical units from the main star, a gas mini-Neptune will orbit. In my system, its name will be Nerea, and it will have a temperature of minus 27 degrees Celsius. It'll have a mass of 4 Earths. Well, I don't like its axial tilt, I'll make it different. It'll be about 3 degrees. Now I'll set up its pounds. It will have 6 colors. Let's start with the first one. Its first color will be like this, the second color like that, the third color, 4th, 5th, and 6th. We can also look at the contrast. Well, yes, it will be even more beautiful like this. And so we got this bluish turquoise gas planet. It looks beautiful. I really like it. Now I'm gonna add moons to it. The first relatively large moon will orbit at a distance of 280,000 kilometers from the planet. Now another moon, it will be the largest in the moon system of this gas planet. It will orbit right here. There will also be small asteroid moons. One of them will orbit here, the second one here, and the third one, for example, here. And they will also orbit further out beyond these large moons. I'll just place them like this. That's it. That's enough. And now I'll set up the largest moons. Let's start with this first one. This moon in my system will be named Eris. Yeah, it's not very big here, only 300 kilometers in radius. I'll at least double its size, 590 kilometers. Well, I don't know, maybe I need to increase it more. It's just too small. Now the radius is 1,181 kilometers. Let it be like this, and the average temperature on it will be minus 23 degrees Celsius. I'll immediately give it a tidal lock to the mini-Neptune, and it will have a very weak magnetic field. Well, Well, I'll set it to a 1/10 of a Gauss. There it is. It will have a thin atmosphere, but before adding it, I'll set up the surface relief. Here, I'll choose custom mode again. I'll make low altitudes like this, medium will be like that, and high altitudes this color. Now, I'll also increase the surface contrast and make the mountains a bit higher. And so we got this interesting moon with such an interesting surface. And now I'll add an atmosphere. It will have a thin atmosphere of carbon dioxide and nitrogen. I'll add carbon dioxide first. There will be only about 2/10 of Mars' atmosphere here, and nitrogen will be 1.5 Mars atmospheres. And so the atmospheric pressure in the end turned out to be only 3/100ths of an atmosphere. That is, a thin atmosphere, just as I wanted. And this is how it looks against the background of its parent planet. Now, I'll set up the second most interesting moon of this planet. Its radius and mass are a bit small. I'll double it, and the radius of this moon will be like half an Earth. And this moon will have life, guys, and its name will be Gaia. On such a moon, it will be 26 degrees Celsius. I'll immediately make a tidal lock to the gas planet and add a magnetic field. The magnetic field strength of this planet will be about half a Gauss. And there it is, it's appeared. Now this moon will get an Earth-like atmosphere. There are atmosphere presets right here. I'll select Earth here and choose the pressure and composition preset, and I'm adding gases to this moon's atmosphere. This way, the pressure on this moon completely matches that of Earth. Vegetation and city lights are turned off here by default. Anyway, I'll turn them on and you can see right away that our moon has become almost entirely green. Pretty cool, right? But it's missing liquid water on the surface. I'll fix that and add some water here. Just like that. Let's add more. I'll hide the atmosphere and clouds. Well, I think this balance of water and land is basically perfect. The temperature spiked a bit here, so I need to adjust it. I'm setting it back to 26 degrees Celsius. There, now everything's great. And now I'll work on the appearance. Anyway, I'll hide the atmosphere and clouds. Low elevations here will be this color, mid-levels will be like this, and I'll make high elevations like that. I'll increase the contrast. Well, I won't mess with the mountain height this time. In the end, this is how the surface of this moon turned out. Basically, it's excellent. And now guys, if we turn off the flashlight and look this way, we can immediately see the city lights, meaning there's already a developed civilization here. I'll turn the display back on, and we've got this interesting moon with life. This is how it looks against the gas planet, and from space, we can see the first 3 stars of this system near it. And I'll also add that the likelihood of life turned out to be over 20%. That's not bad. Overall, the moon system looks pretty good. Now the star Nox will get its own planets. The first planet will orbit at a distance of 0.02 astronomical units from it. This planet will be in the star's red zone. I'll name the planet Vesper, and according to my plan, this planet won't have an atmosphere. I'll give it a tidal lock to the star right away. It would happen here anyway, and I'm completely removing all gases from the composition. That's it. Now it's just a rocky, airless world. Since it's tidally locked, the temperatures on the day and night sides will be completely different. The max temperature on the day side will reach 55 degrees Celsius, while the minimum temperature here will be minus 137 degrees. Now I'll set the surface colors. Custom mode. Low elevations will be like this, mid-levels will be this color, and high ones will be like that. I'll max out the contrast and slightly increase the elevations. And in the end, this is the planet we got. The second planet of this star will orbit at a distance of 0.031 astronomical units. This planet will also be in the red zone. I'll set this planet to be tidally locked to the star right away. The planet will be named Leyland. This planet will have a thin atmosphere, so to do that, I'll have to clear out the current atmosphere. I'll come back to the atmosphere later. First, I'll set up the appearance of this planet. Low elevations here will be this color, I'll make mid-levels like this, and high ones will be like that. I'll increase the contrast and make the mountains a bit higher. As a result, the surface turned out like this. Now I'll work on creating a thin atmosphere. Let's have a little nitrogen here. I'll make it 1.5 Martian atmospheres, and also add a bit of oxygen. Let's also have some argon, about 0.3 Martian atmospheres. And I think I can just add a little methane here for fun. And also, let there be carbon dioxide, about 1 Martian atmosphere. As a result, the surface pressure is only 2/100ths of an atmosphere. But, you know, I'll make this atmosphere a bit denser. Let's have twice as much carbon dioxide, and I'll also set twice as much nitrogen as before. Well, now it's almost 4/100ths of an atmosphere. Let it be like that. The minimum temperature here will be minus 147 degrees and the maximum 80 degrees Celsius. For some reason, the maximum temperature won't set at all. Well, let it be 28 degrees then. What can you do? Anyway, by clicking this stabilize temperature button, this is what happened. And let me try to change the value again. It'll be 80 degrees on the lit side and the minimum temperature will be minus 147 degrees. Well, it turned out something like that. Okay, so this is the second planet of the star Nox. And the third planet will be the most interesting one here. It'll orbit at a distance of 0.046 astronomical units from the star Nox, and as you can see, it'll already be in the green zone. I'll call this planet Termina. I'll give it a title lock to the star right away. Anyway guys, this planet will have life, but life will only be in the Terminator zone. I'll make it brighter because the planet looks very dim. And first of all, I'll lower the sea level, because there's too much water here. Like this, for example. Secondly, I need to completely change the atmosphere. I'll simply delete the current one. But before adding Earth's atmosphere, I want to add a magnetic field to this planet. Since it's a red dwarf, a strong magnetic field is desirable. I'll even make a magnetic field with a strength of 2 Gauss. A nice magnetic field like this has appeared. It turns out I also accidentally deleted all the water. Well, whatever. I'll add it again later. But for now, I'll add the atmosphere. Again, in the same way, the Earth atmosphere preset, and here the pressure and composition preset. Adding gases to the atmosphere, and now I'll add water right away. Let there be about this much. And I'll turn on the display of vegetation and city lights here. And as we can see, everything has become green again. I'll make everything brighter once more, so you can see it all more clearly. Before continuing the setup, I'll adjust the appearance of this planet. I'll use custom mode and change the color palette. Low altitudes will be this color, medium ones like this, and high ones like that. I'll increase the contrast to the maximum and make the mountains on the planet a bit bigger. Absbon. And now the temperature. The temperature will vary in different parts of this planet since we have a tidal lock here. I want to create life only in the Terminator zone, and the minimum temperature here will be minus 130 degrees Celsius on the dark side, and the maximum temperature in the brightest spots will be 103 degrees Celsius. So far, everything hasn't rendered very well here. I take it I need to fast forward time or try clicking this button. Ooh, there are a lot of desert areas right away. Well, anyway, let's adjust the temperature here again. I'm setting the max to 103 degrees Celsius and the min to minus 130. Basically, I see that I can't do without fast forwarding time. Well, then I'll speed up time and we'll see how this planet transforms. Well, we see that one part is starting to freeze. Right here, the ice has really started to spread. In the end, I got a planet that looks like this. I'll make it brighter. On this side, everything's completely frozen over. And this side, which is lit by the star, is mostly desert. But in the Terminator zone, as we see, there's life stretching toward the North Pole. And also, if we look at the South Pole, there's vegetation here too. Well, for some reason, there's no vegetation in this part. Even the ice is moving into this desert here. It turned out to be an interesting planet. The likelihood of life there is 13%, and it also has a small moon. I'll place that at a distance of 30,000 kilometers from the planet. I'll call it Umbriel, after one of the moons of Uranus. Let's also customize the appearance of the surface. I'll make the low elevations like this, the mid ones like this, and the high ones like this. I'll increase the contrast. And so, in the end, I've got a moon like this. This is how it looks against the planet, the star, and the other stars in the system. And the final fourth planet of the star Nox will be a gas giant, orbiting at a distance of 0.114 astronomical units from the star. The gas giant will be named Titanor, and its mass will be about 0.68 times the mass of Jupiter, and so its radius will be slightly smaller than Jupiter's. It won't have a tidal lock to the star anymore, but its minimum temperature will be minus 130 degrees Celsius, and the maximum only minus 45 degrees. It will have a small orbital eccentricity of 0.041. It will have 6 different colors, and I'll start setting up its colors. The first color will be like this. I'll make the second band like this, and the third like this. The fourth will be like this, the fifth like this, and the sixth and final one will be this color. I'm increasing the contrast, and we've got this interesting, beautiful gas giant with cool purple shades. But this gas giant will also get rings, though I'll add those a bit later. For now, I'll add some moons to it. The first large moon will orbit at a distance of 250,000 kilometers from it, and there will be another large moon at this distance. There will also be small asteroid moons here. I'll place the first 2 near the planet. More of these asteroid moons will orbit somewhere around here, beyond these large moons. Now, I'll start setting up the first large moon. The first moon will be called Infera. This moon will somewhat resemble Venus. As you'll see, it'll have a thick atmosphere, so for that to happen, I need to create a magnetosphere right away. It won't be very powerful here, just 0.25 Gauss. So there's the magnetosphere, but before that, I'll definitely customize the surface appearance. I'll make low altitudes this color, mid-range like this, and low ones like that, increasing the contrast. And we've got this glowing hot surface, somewhat reminiscent of the surface of Venus. And now I'm gonna create a dense atmosphere here. I'll add 1 Earth atmosphere of argon here. Also, there'll be 2.5 Earth atmospheres of sulfur dioxide, a bit of oxygen, but the main component of the atmosphere will be carbon dioxide. There'll be 45 Earth atmospheres over here. Well, and there'll be 4 Earth atmospheres of nitrogen here. And as a result, the pressure on this moon is 128 atmospheres, which is even more than on Venus. And so the average temperature here will be 481 degrees Celsius. Something happened and gases started escaping from this moon. I'll double the mass of this moon. Maybe that'll help retain these gases. And as we can see, yeah, the gases actually stopped escaping after that. So in the end, we got a moon that's very similar to Venus. If we hide the atmosphere and clouds, we see the same surface that I just configured. Now I'll set up the second moon. Its name will be Cryon, and this moon will have liquid methane and possibly nitrogen on its surface. Also, before creating the atmosphere, I'll change the surface appearance. I'll make low altitude like this, mid-range will be this color, and high ones will be like that. And I'm increasing the contrast. I can even make the mountains a bit higher. There, that turned out pretty well. By the way, we can see the gas giant too. Cool! Now I'll add gases to the atmosphere. I'll set nitrogen to 0.4 Earth atmospheres, and methane will be half that, 0.2 Earth atmospheres. We've got this nitrogen-methane atmosphere, but it's gonna be very cold on this moon. The average temperature will be minus 182 degrees Celsius. And thanks to this low temperature, liquid methane and possibly even liquid nitrogen can form on the surface of this moon. Well, as we can see, it looks like liquid nitrogen has appeared. I'll hide the atmosphere in clugs. You can see these turquoise bodies of water. That's how it looks in the simulator. Well, it's most likely liquid methane, not nitrogen, guys. If you look at the moon's composition, the ocean composition, it says there's only liquid methane. For some reason, there's no liquid nitrogen yet. Maybe the temperature is too high for it to be in liquid form. Well, anyway, let there just be liquid methane seas then. And so, in the end, I got a moon like this. And we still have the brown dwarf Umbra here, and it'll have 2 planets and an asteroid belt. And the first planet will orbit at a distance of 0.025 astronomical units. It'll be a cold, icy world. I'll call it Glacies. The simulator provided a planet with water here, but I'll freeze it by setting the temperature to minus 181 degrees Celsius. Well, we see the water didn't freeze, but if we fast forward time, it'll all turn into ice anyway. But I don't have to wait for that and can just go ahead and freeze it manually. Now I'll customize the appearance of this planet. I'll set low altitudes to this color, mid-range will be like this, and high ones like that. And I'm increasing the contrast as always. And we can make the mountains a bit higher, and in the end, we got a planet like this. Here it is against the brown dwarf. And we see how the brown dwarf lights up the surface from this side, and over here, it's being lit by other stars. The brown dwarf will have another planet, orbiting at a distance of 0.062 astronomical units. This planet will also be very cold and icy. Its name is going to be Abyss. Its surface temperature will be as low as minus 218 degrees Celsius. So all the water that's on it right now will be frozen solid. I'll just go ahead and freeze it all. And as always, I'll adjust its appearance. I'll make low altitudes this color, mid altitudes that color, and high spots will have this color palette. And I'm turning up the contrast. And I think it wouldn't hurt to increase the mountains a bit. So basically, we have this frozen, distant, cold planet. And here it is, illuminated by the brown dwarf. And from this planet's orbit, the brown dwarf already looks very small. This planet will also have 3 asteroid moons. The first one here, the second one there, and I'll put the third one, say, right here. And now you can see their orbits. And beyond these planets, the brown dwarf will also have its own asteroid belt. What's added in? There, I've made it so this asteroid belt is clearly visible. You have to admit, it turned out pretty cool. I'll show it to you from this angle too, in one plane. Yeah, it looks great. So this is the final brown dwarf system. I also have some unfinished business in the Nox star system, specifically with the gas giant Titanor. Here I am by this gas giant, we can see shadows on it from its 2 large moons, and I mustn't forget to add rings to this gas giant. So it's gonna have a ring system like this. And now the moon system of this gas giant looks beautiful like this. The moon's orbits are tilted just like its rings, and we see that these 2 closest asteroid moons are orbiting inside the rings. And overall, the moon system looks like this. Now I'll show you a few views. Here's a moon that looks like Venus against its parent planet with rings. And here's the view of the gas giant from near the second large moon. And overall, the Nox star system turned out like this. So all in all, this is the system I've created. Let me know what you think about it in the comments. If I did something wrong somewhere, let me know in the comments too. And don't forget to leave a like. Thank you very much.